For this lecture, I'm going to be talking about spermatogenesis. Spermatogenesis will be taking place from the time that sperm first begin through their maturation process until they are mature to actually fertilize an egg to create life. First off, a simple definition of spermatogenesis. It is the process by which stem cells develop into mature spermatozoa. There are three different phases of spermatogenesis. The first phase is spermatocytogenesis, which is mitosis, meiosis, and spermiogenesis. First, we will talk about spermatocytogenesis. Spermatocytogenesis begins with stem cells, which are type A spermatogonia. These are singular cells that divide mitotically to replace themselves and produce cells that begin differentiation into type B spermatogonium. As we can see here, one type A spermatogonium becomes two intermediate spermatogonium, and then two more type A spermatogonium and two type B spermatogonium. The type A will continue to proliferate, allowing us to continue to produce spermatogonium. They have a spherical or oval nuclei, and they rest on the basement membrane. The second phase is the phase of meiosis. Cell and prophase of the first meiotic division are primary spermatocytes. They're characterized with highly condensed chromosomes, giving the nucleus of a coarse chromatin pattern and an intermediate position in the seminiferous epithelium. This is a long stage, so many primary spermatocytes can be seen. Primary spermatocytes go through the first meiotic divisions and become secondary spermatocytes, as we see here, where they then go into the second meiotic division to create they go through the second meiotic division to create spermatids. So we start off with two primary spermatocytes that came from the type A to type B spermatogonium, now spermatocytes. We have two of them that undergo meiosis to create four copies. These are four identical spermatocytes. Those four identical spermatocytes then undergo meiosis 2 to create four identical spermatids. These would be diploid, and these are now haploid. They're haploid because when they become mature sperm, they have to have half of the set of chromosomes so that when they combine with the egg, they can create the full set. As I mentioned already, the products of secondary meiotic division are spermatids. They're spherical cells with interphase nuclei positioned high in the epithelium. They go through a metamorphosis into spermatozoa, so they're and as you notice here, it looks like there's this like a bridge between the spermatids. This bridge is necessary for the maturation of the spermatids into spermatozoa. It allows them to all communicate and all proliferate at the same time. So the final phase of spermatogenesis is spermiogenesis. This is the actual maturation of spermatids to spermatozoa, which are functional sperm as we know them. No further meiosis or mitosis will occur. During spermiogenesis, the acrosome forms, the flagellar apparatus forms, and most excess cytoplasm, which is considered the residual body, is separated and left in the Sertoli cell. Spermatozoa are released into the lumen of the seminiferous tubule, and a small amount of excess cytoplasm is shed later in the epididymis. So as we can see here, these will be the residual bodies that will be left after the sperm mature into spermatozoa that can actually function and enter the seminiferous tubule. If we were to look at a cross-section of the seminiferous tubule, we would see every type of these different cells all the way to mature sperm. It's pretty interesting, actually, when you can see the type A spermatogonium, type B, and you can really see the entire process if you get a good cross-section all the way through spermatozoa. Spermiogenesis is metamorphosis that will create the final mature sperm that can then go on and fertilize the egg. One further detail that we will talk about is the transition of spermatid to spermatozoa that can actually fertilize the egg itself. They have to go through what's called an acrosomal interaction, which is essentially a peeling back of the cap of the head of the sperm, which allows the acrosome to be, for a lack of a better term, uncovered. So the acrosome will then be uncovered. This is what's going to penetrate the jelly layer of the egg and actually react with the egg to insert the nuclei of the sperm into the egg itself to fertilize it. There is one final detail that I would like to discuss, and that is that of the blood-testes barrier. Much like the blood-brain barrier that keeps things from the blood from entering the brain, the blood-testes barrier keeps the body from attacking the sperm, because sperm or spermatozoa can be seen as a foreign body, and this keeps it from inducing an immune response that may attack the mature spermatozoa, causing both infection and infertility, or sterilization as we will know it. This concludes my lecture on spermatogenesis. I hope you enjoyed it. Thank you.